section 6.4, a little bit of a in-between here. We're looking at the parent functions. We need to remember how to graph the absolute value graph and also the parabola. We're going to be doing more of our parent function graphs in just a couple sections. So this first one is the absolute value graph, and remember when you look at your equation, it looks like this. Y is equal to the absolute value of x. We're going to have three go-to points that we're going to use every single time to help us graph these and then shift them. The points that I want you to use are negative 1, 1, right here, 0, 0 in the middle, and then 1, 1, right here. The shape of your absolute value must always be a V. Please be very careful that it is pointed at the bottom and not rounded. And then the domain. Domain, remember, refers to what x numbers can be used. For the absolute value, we could plug in any x number, positive, negative, and 0, and still get an answer. So we call that all real numbers. And the range refers to the y values. What y numbers will I get for my answers? Well, since each leg to this is above 0, there's nothing that's down here at all, we refer to that as y will be greater than or equal to 0. When we shift the absolute value graph, I want you to do your shifts in this order. First thing I want you to look at is what's happening inside the absolute value sign. You will do the opposite of whatever it says. And remember, this moves your x coordinate to the left or to the right. The second thing we're going to do is look for a multiplier. This is called a stretch number that's out here in the front. That's the a value. If you have that a value, you're going to take your y term of your go-to point and multiply by that a value. And then the third thing that we do is add or subtract whatever the k number is in the back. And this time you do the exact same as whatever the sign says. This will then move your graph up or down depending on if it's a plus or a minus in the back. This particular example, y equals absolute value of x plus 3 minus 2. Your go-to points to start with, remember again, are negative 1, 1, 0, 0, and 1, 1. So the first thing we do is change the x coordinate. Do the opposite of what this says. It says plus 3, so I need to subtract 3 from every x coordinate. That puts us at negative 4. The next number, 0 minus 3, is negative 3, and 1 subtract 3 is negative 2. The x coordinate is now done. I will not change the x any longer. Now I move to the y values. The first thing I do to a y value is look for a stretch number in the front. I don't have anything. It's just like an invisible 1 right here, which means I'm multiplying by 1. It doesn't change my y number. So the next thing I do will be to move to the back. I will do exactly what it says. If it says subtract 2, then that's what I will do. I will subtract 2 to every y value. 1 subtract 2 is negative 1. 0 subtract 2 is negative 2. 1 subtract 2 is negative 1. And then I can plot these. Negative 4, negative 1, right here. Negative 3, negative 2. Negative 2, negative 1. When I connect, remember, I will be in the shape of a V. Make sure it is pointed. And then we have to answer the domain and range question. The domain for these will always be all reals. I can put in anything I want in for x and I will come up with an answer. The range, though, has now been changed. I am not just above 0 any longer. I have shifted to be, and if you look right here, this will give it away. I have shifted so that it will be everything above the number negative 2. If you look at your graph and kind of project sideways, that's the lowest that this graph gets, is at negative 2. So the way I write that will say my range will be all y numbers greater than or equal to negative 2. Here's the next one. Y equals negative 2 times the absolute value of x minus 4 and then plus 3. Again, we always start with our go-to points, negative 1, 1, 0, 0, 1, 1. And the first thing I do is look inside. If it says minus 4, I do the opposite, which is plus 4. I need to add 4 to each x coordinate. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. X coordinate is done. Now move to your y value. Second thing I do in my equation is the stretch number. It says I have to multiply by -2. Remember, there's a little teeny dot right there, which means multiply. I'll take my y value and multiply by -2. 1 times -2 is -2. 0 times -2, still 0. 1 times -2, -2. Now I have to do the back. The back says add 3, so I will now do an add 3 to this new y value that I got. X number stays the same, remember, every time. -2 plus 3 is 1, 0 plus 3 is 3, -2 plus 3 is 1. And now I'm ready to plot. 3, 1, 4, 3, and 5, 1. Puts us right there. This one is a V again, but because I had a negative sign in the front, this has been flipped upside down. Make sure your V is pointed, and then we answer the domain and range question. Domain, all reals every single time. Range. I'm going to be underneath a particular spot. Well, where am I underneath? This number in the back gives it away. I don't go any higher than 3. So this is all y numbers less than or equal to 3. The parabola, also known as the quadratic function. Parabola is now in the shape of a U. Remember, we did this in chapter 4. The go-to points for the parabola are the exact same go-to points as we do for the absolute value graph, except it's rounded at the bottom instead of pointed. The domain and the range are also the same as the absolute value. Domain is all real numbers, and the range is everything greater than or equal to 0, until I start shifting it, and then it'll move. The shifts will be the exact same as we do for every parent function. The first thing we do is change the x number, do the opposite of what it says. Second thing we do is the multiplier. If you have an a number in the front, you multiply your y value times that. And the third thing that we do is add or subtract the k number, do exactly the same as the sign says. That will shift your graph either up or down. First example, y equals x plus 1 squared minus 3. First thing I do is change the x number. It says plus 1, I do the opposite. I will subtract 1 to the x number that I've got. -1 minus 1, -2. 0 subtract 1, and 1 subtract 1. X numbers are now done. Move to the y number. I do not have to multiply the y number times anything since it's just a 1. So I move to here next. This is the third thing we do. First, second, third. It tells me to subtract 3, so that's exactly what I'm going to do. Subtract 3 from each y value. 1 subtract 3, -2. 0 subtract 3, and 1 subtract 3. And now we're ready to graph. -2, -2. -1, -3. 0, -2. And we will sketch. We're in the parabola, so remember this one should be rounded. This one is facing up. We didn't have a flip on that one. And then we do the domain and range question. Domain, all the time, every time, for the parabola is all reals. And the range. This has now been shifted downward 3 spots, which means the lowest I get on my y value is at -3. So it will be all y's greater than or equal to -3. And let's try this one. 3 times x minus 2 squared plus 2. Go-to points. Let's change the go-to points with the x first. It says -2, we plus 2. -1 plus 2, 0 plus 2, 1 plus 2. You're done moving your x coordinates. Y values. Now I have to multiply my y values times 3. 1 times 3, 0 times 3, 1 times 3. And now I've got a number in the back. I have to take each of my y values and add what I see. X number stays the same. Y number. 3 plus 2, now 5. 0 plus 2, and 3 plus 2. and these should be my ending points. Go ahead and make your sketch. 1, 5, 2, 2, and 3, 5. Make sure it is rounded. It's fairly skinny. Make sure it's rounded at the bottom, and then you can answer the domain question all the time. All reals. Range. The lowest I get on this y value is positive 2. Should be that number right there. Y is greater than or equal to positive 2. The school that I taught at in Grenada was called Happy Hill Secondary School. All right, that's it for your samples for your parent function, absolute value, and parabola graphs. Your worksheet for tomorrow will be fairly easy if you understood this. Now you can go to Skyward in your online quiz for 6.4 parent function graphs.